Hi guys, welcome back to my channel. Please like, share and subscribe. So we are carrying on with probability, which is the probability tree. In the last session we went through question 1, 2 and 3. So today we're on question 4. There are 10 socks in a drawer. 7 of the socks are brown, 7 of the socks are grey. Bevan takes at random 2 socks from the drawer at the same time. Complete the probability tree diagram. So, if he takes 2 socks at random at the same time, when we start, first we know that the brown socks in the bag is 7 out of 10, and we've been told that the grey socks is 3. So we have 3 grey socks out of 10 in the bag. That's the first stock before he took anything. So the probability of taking, so he took 2 socks at random, probability of taking a brown after taking a brown the first time. Okay, so if he takes a brown the first time, right, we will be left with 9 socks in the bag. So the first time he took 1 sock, probability of taking a brown is 7 out of 10. Now if he has taken a brown the first time, so he removes 1 brown, we will be left with 6 browns in the bag. Now but if he took a brown the first time and then the second time he takes a grey, okay, so he has not taken a grey before, so we are still left with 3 greys in the bag. So probability of taking a grey after taking a brown is 3 nights, or taking a brown after taking a brown the first time is 6 nights. Now if the first time he took the sock, he took a grey, so probability of taking a grey the first time is 310. Now he has taken the grey sock and didn't replace it, so we have 9 socks left in the bag or in the drawer. So 9 socks left. Now if he took a grey the first time, then that means we have 7 browns left, so probability of taking a brown will be 7 nights the second time. But if he took a grey the first time, we'll be left with 2 grey socks in the bag, so probability of taking a grey the second time will be 2 out of 9. Now the B question says, work out the probability that Bevan takes 2 socks of the same color. Let me just make that a bit clearer. So 2 socks of the same color. Okay, so when it is 2 socks of the same color, that means that probability that he took brown and a brown, or he took grey and a grey. Okay, so to be probability that he took brown and, so a brown the first time and a brown the second time, so first time, second time, or probability that he took a grey the first time and probability that he took a grey the second time. Okay, so I'm going to introduce a bracket, because remember it says probability of Bevan taking 2 socks of the same color. Okay, so if he took brown the first time, which is that 7 out of 10, and means multiplication in probability, and he took brown the second time, 6 nights. Or means to add, he took grey the first time as 3/10, and he took grey the second time That is 2 nights. So 42, 6 times 7 is 42, 10 times 9 is 90, 3 times 2 is 6, 10 times 9 is 90, and if we add that together, that will be 48 90th. That here. And that's equivalent to 24 45th. Okay, so moving on to question 5. Martin and Luke are students in the same maths class. The probability that Martin will bring a calculator to a lesson is 0.8. The probability that Luke will bring a calculator to a lesson is 0.6. Complete the probability diagram. Okay, so first we need to figure out, so probability that Martin will bring a calculator is 0.8, right? Now if Martin brings a calculator, probability that Martin will not, so will not bring a calculator would then be 1 minus 0.8, and that is 0.2. Now if we look at Luke, probability that Luke will bring a calculator, we've been told that that is 0.6. So probability that Luke will not bring a calculator is 1 subtract 0.8, and that is wrong. That's meant to be 0.6, not 0.8. So Luke is 0.6, and then 1 subtract 0.6, that is 0.4. Okay, so with that in mind, we are then going to complete this probability diagram here. So if Martin brings a calculator, is 0.8, probability that he won't bring a calculator, we've worked it out here to 0.2. Now, if Martin had brought a calculator, then the probability, if Martin had brought a calculator, then the probability that Luke brings a calculator is 0.6. Therefore, the probability that Luke does not bring a calculator, we work that out here to be 0.4. Now, we've been told that the probability that Luke brings a calculator is 0.6. So we're going to still fill the same thing there. So whether Martin brings a calculator or does not bring a calculator, Luke will always be 0.6, 0.6 if he brings a calculator, and it will always be 0.4 if he does not bring a calculator. Okay. Now the next question then says to work out the probability, work out the probability that Martin and Luke will not bring a calculator to a lesson. So that means the probability that Martin will not bring a calculator and Luke will not bring a calculator. So Martin will not bring a calculator and Luke will not bring a calculator. So I believe that Martin will not bring a calculator is 0.2. and is multiplication, probability that Luke will not bring a calculator is 0.4. So 0.2 times 0.4, that's 0.08. Okay, moving on to question 6. In a bag, there are 5 red counters and 4 blue counters. Suki takes at random 2 counters from the bag. Work out the probability that the counters will each have a different color. Okay, so first we need to establish what we have. So probability of a red counter, we have 5 red counters out of 9, and then we have 4 blue counters out of 9, because they only mentioned 5 red counters and 4 blue counters, so that means 9 in total. Now Suki takes at random 2 counters from the bag. Work out the probability that the counters will each have different color. Okay, so we've not been told which one she took first. Okay, but she would have taken one first and then taken the other one first. So she either took a red one first, so probability of a red one first, and then took a blue one next, right? Or the first time she probably picked a blue first and then picked a red next. Okay, so but what we know is that she has picked 2 colors at random. They didn't tell us in what order, but either of these orders are possible. So red first and then picking a blue, or a blue first and picking a red. So now probability of she picking a red, she picked a red first, 5 out of 9, right? And means times. Now by the time she picks 1 red out of the bag, so a red counter is gone, we will be left with 8 counters in the bag. But we still have all the 4 blues, so 4, 8. Or means addition, she may have picked the blue first, so 4 knight, and means times. Once she takes 1 blue counter out of the bag, we will be left with 8 counters, but there are 5 red counters still in the bag. Okay, so now working with this, 5 times 4 is 20, 9 times 8 is 72, plus 5 times 4, 20, 9 times 8 is 72, 40 out of 72. So we can simplify that if we choose. Divide both sides by 10. Divide both sides by 4 rather. And we can even go further. And moving on to question 7. Question 7 says Tom and Sam each take a driving test. So let me make that a bit clearer. The probability that Tom will pass the driving test is 0.8. The probability that Sam will pass the driving test is 0.6. Complete the probability tree diagram. Okay, so let's go to so we've been told here probability that Tom will pass is 0.8. So the probability that Tom will then fail is 1 minus 0.8, that's 0.2. Now, if the probability that Sam passes is 0.6, probability that Sam fails is 1 minus 0.6, that's 0.4. And that's the same thing here, 0.4. Now, the first question says work out the probability that both Tom and Sam will pass the driving test. So both Tom and Sam will pass. So this is Tom pass, Sam pass. Okay, so we're following that line. Probability that Tom will pass is that, probability that Sam will pass is that. So Tom passes and Sam passes. So Tom passing is 0.8 and its times probability that Sam passes is 0.6. Okay, so 0.8 times 0.6 0.48. Okay, next one says work out the probability that only one of them will pass the driving test. So if only one of them will pass the driving test, right? So that means that there's a probability that Tom passes and Sam fails. Okay. Or probability that Tom fails and Sam passes. So whatever the case may be, only one of them passes, right? So the probability that Tom passes is 0.8, that one there, so we're going to write it down. And means times. Now if Tom passes, probability that Sam fails is 0.4. I'll put that down here. I'm introducing a bracket, or means to add. Now Tom fails, so this is Tom, probability that he fails is 0.2. And Sam passes, so Tom fails but Sam passes, 0.6. So you follow, it's almost like following the arrow. So 0.6. So 0.8 times 0.4, 0.32 plus 0.2 times 0.6, 0.12. If we add that together, we get 0.44. Okay, on to question 8. Matthew puts 3 red counters and 5 blue counters in a bag. He takes at random a counter from the bag. So let's just remember 3 red, 5 blue. That means in total we have 8 counters altogether. Now, he takes at random a counter from the bag. He writes down the color of the counter. He puts the counter in the bag again. So this is one of those ones where he returns it back into the bag. He then takes at random a second counter from the bag. Complete the probability diagram. So if there are 3 out of 8 red counters, then there'll be 5 out of 8 for blue counters. Now if he takes a red counter at random and puts it back, probability of taking a red the second time is still 3 out of 8 because he did not get rid of that counter, he put it back in the bag. Now if he takes a red counter the first time and puts the red counter back, because remember it says puts the counter in the bag again. Alright, so that means that we still have 8 counters, and there are 5 out of them there. And here we still have 8 counters, there are 3 reds, and here we still have 8 counters and there are 5 there. Okay, so work out the probability that Matthew takes 2 red counters. So the probability that he takes a red counter the first time and then takes a red counter the second time. Okay. So probability that he takes a red the first time and probability that he takes a red the second time. So the first time 3 out of 8, second time 3 out of 8. So 3 out of 8 times 3 out of 8. 8 times 8 was 64. So our answer for that is 964. Now on to question 9. In a game of chess, a player can either win, draw, or lose. The probability that Vichy wins any game of chess is 0.5. The probability that Vichy draws any game of chess is 0.3. So in this case here, win, draw, or lose, if we were to add them all together, it should be adding up to 1. Okay, so on here, before we even answer the question, I would say the probability of win plus draw plus lose is equal to 1. So if the probability of winning is 0.5, the probability of draw 0.3, then the probability of losing the game will then be 1 minus 0.8, which is equal to 0.2. Okay, now with that out of the way, they said that Vichy plays 2 games of chess. So complete the probability tree diagram. So probability of a win is 0.5, probability of a draw is 0.3, so probability of a lose 0.2. Now if he wins, it's still all repeating itself. Probability of a win we have 0.5, a draw 0.3, and a lose 0.2. A win 0.5, 0.3, 0.2, 0.5, 0.3, 0.2. Okay. Now work out the probability that Vichy will win both games. So he played 2 games, right? The probability that he would win both games is the probability that he wins the first game and then wins the second game. So you just trace it following that line there. Wins 0.5 and then wins again 0.5. Wins and wins. So he wins the first time and wins the second time. So probability of winning is 0.5 and its times probability of winning again is 0.5, and 0.5 times 0.5 is 0.25. Probability of winning Our answer is 0.25. Okay, that brings us to the final question, question number 10. There are 10 students in a class. 6 of the students are boys and 4 of the students are girls. 3 students are picked at random from the class to form a team. Work out the probability that the team consists of 1 girl and 2 boys. Okay, so what we're going to have here, we've not been given any specific order in which they've selected the 3 students. Okay, so first we need to remember that probability of boys, so we've been told there are 10 students, so 6 out of 10 boys, 6 boys out of 10 students, and for girls, 4 girls out of 10 students. Okay, so there is a probability that the first person they picked is a boy. So first they pick a boy, and next they pick a girl, and next they pick a boy. So that will give us 2 boys and a girl. Or they may have first picked a boy and second a boy and the third person a girl. Okay, so still we have 2 boys and a girl. Or they may have picked the girl first and then picked a boy and then pick the third person who is a boy. So either ways, again, we have 2 boys and a girl, but we were not told the order in which they were picked, so we have to consider that. So if the first time they picked a boy, right, so probability of picking a boy the first time will be 6 out of 10. Okay, and now if one person has gone out of the class, okay, so we are left with 9 students, and probability of picking a girl out of those 9 is 4 out of 9. Okay, now a second student has gone out, so now we're left with 8 students. Okay, and out of those 8 students, 1 boy had gone out, so we're left with 5 boys. Okay, or the first time they picked a boy, 6 out of 10, right? Now we have 9 students left, okay? And out of those 9 students, 1 boy had already gone, so we are left with 5 boys. And 2 students are now gone out of the class, we're left with 8, but we still have all 4 girls. Okay, so probability of having a girl. Or it could have been the girl picked first, so 4 out of 10 students. Now if 1 student has gone out of the class, so we've got the girl out, we have 9 students left, and we've still got all the 6 boys in the class. Now we've sent out a boy and a girl, we're left with 8 students in there. Out of the 8, we've sent out a boy, so we're left with 5 out of 8. So now we can solve this. 9 times 8 is 72 times 10, 720. 4 times 5 is 20. 20 times 6, got 180 here. that's meant to be 120 rather, not 180. 20 times 6 is 120. Okay. And then here we've got 720 again. And 120 plus 720 again, and then 120. So if we add all together, we'll have 360 plus 720. So our final answer is 360 out of 720. Alright, so that brings us to the end of probability tree diagram. Thanks for joining me on this. Please share, like, and subscribe. That would really help me a lot. See you in the next video. Bye.